Hi guys, we're doing notes a little differently today because I'm still meeting with groups of students. So what I want you to do first is turn to page 119 in your textbook and go ahead and get there now. Okay, hopefully you're on page 119. I want you to read pages 119 and 120 and then you may go ahead and resume the video. Thanks. All right, great, you're back. Now we're going to go ahead and fill out these notes together so you don't have to do it on your own. I'm going to go ahead and let's use a blue color. All right, so the first thing that you read was the definition of a relative age. Let's go ahead and write down that relative age is the age of an event or object in relation to other events or objects. What's the general age? General age, so we're estimating for relative age. Think of it as an estimation. Now, other things that you should have read, how do sedimentary layers reveal relative age? We have the law of superposition, which says that the youngest is on top, and it goes down to the oldest on bottom. So the very top layer is your youngest layer, your very bottom layer is your oldest layer. And then I do want you to go ahead and sketch and label the rock pictures on the bottom of 120. So you're sketching these two pictures for me, please. Here's my beautiful works. I know I'm really good. Go ahead and do that, and you may resume the video when you're finished. Okay, now that you have an awesome picture, let's go ahead and read page 121 for me, please. When you're finished reading, you may resume the video. All right, you're back. So let's go ahead and fill out this other top portion of the notes. We are going to do, how do streaks of igneous rock in the midst of sedimentary layers reveal relative age? That was the law of cross-cutting relationships. So the law of cross-cutting relationships says that anything that cuts through is younger than the rock layer that it cuts. And an example would be like lava and igneous rocks. I want you to go ahead and sketch and label the middle picture on page 121. So if you just label, you can just draw the center picture if you want. If you'd like to sketch all three, you may also do that. I went ahead and sketched all three, as you can see here. Go ahead and do that. When you're finished, you may resume the video. Okay, our next section, it says, how do index fossils reveal relative age? So, organisms that were fossilized in rock must have lived in the same time span as the rock. So anytime that we have a fossil that has been created inside that rock, we know that the rock and the organism that is inside of that rock must have been at the same exact time frame, give or take a few years, obviously, one way or the other. And what I want you to do next, sketch what you think your pet would look like as a fossil. I have a dog, as you guys know. No, my dog's name is not Chowder, but my dog's name is Honey. And so I'm a really, really, really awesome artist. So there's my dog. Pretty awesome, I know. And go ahead and pause your video and create your sketch and resume when you're finished. Okay, I want you to go ahead and read page 122 all the way to 125. Sorry, I was just double checking those pages really quick. 122 to 125. So go ahead and pause the video and then you may take notes afterwards. Go ahead and read. All right, great, you're back. So first thing we are going to do is fill out your definition for absolute age. That is the actual age of an event or object. Think it's the exact date. So this would be no different than your actual birth date. The last one, relative age, was just, I'm around 10 to 15 years old. This is, I am 13 years, 27 days, or I am 14 years, 2 months, and 1 day. It's the exact age of how old something is. Now, you went on and read about half-life. Now, for a lot of you, half-life may be a little above your head. For some of you, you've already talked about half-life in possibly algebra class, and this is something that you'll continue talking about through high school. So let's go ahead and get the definition down for half-life. That is, the color, length of time it takes for half of the atoms in a sample of a radioactive element to change from an unstable form into another form. And if you haven't talked about this in algebra, it may be coming later on when you get to the high school as well. I cannot remember if Miss Pinchilla teaches that or not. I will have to ask her about that today, so that's a reminder for myself. Now, what I would like for you to do is go ahead and sketch the picture on 123. This one for me, please. Make that bar graph. I would label all the pieces so it looks something like this. Hopefully you guys can see that. All right, and that is it for geologic dating. We basically summarized this section into only a few short notes. Hopefully this was an easy section for you, and we will move on to fossil notes. Thanks, guys. Have a great day.